Good morning, good morning, good morning, good morning. Welcome to the lesson number 4 of that class of science. Today we're going to see a new lesson and in an important topic. And let's go. Okay, raising up. Uh, this is the topic, raising up, right? Why do some things float and while others sink? What does mean float? Is when one object is on the water and it's not going to go on the bottom or under the end, right? So other sink, what does mean sink? The opposite of float. The opposite of float, right? Something that is not going to float is going to be on there, inside the water. Lie on your back in a swimming pool, right? If you will float, why don't you sink to the bottom? When an object is put into the water, it displaces or pushes aside some of the water, some of the water. Imagine you place a block of wood that weighs 2 ounces, right, into a glass of water. The wood will displace 2 ounces of the water. But the name of this is the buoyancy force. What is the buoyancy force? It's the force of water that was pushed aside. This force pushes up on the object and causes it to float. Right? The video that Mr. Marvin gave you about YouTube explained much better this topic and is with one experiment about how the things float and why some things float and others sink, right? So if something is very dense, the atoms and molecules are packed together tightly. Metal, like iron, is denser. This is the magic word, dense. Dense. What does mean dense? Is when one is the form of one object, right? If it's heavy or not heavy, and the consistency and or the body, right? For example, the dance of one car is not the same of one dance of one bus. It's very different, right? The bus is heavier than the car, for example, right? So the iron, the metal and iron, is denser than wood. A piece of iron will weigh more than a piece of wood of the same size. If you put it in the glass of water, it will sink because it is denser than the water. Do the following experiment. Do the following experiment to see buoyancy in action. Okay, this is an experiment that you can make in your house. You can do it with other materials. Do it with a bottle of plastic, or do it with a spoon or a metal spoon, and you're going to see what things float and what things sink, right? So in this part, explain the materials and the steps how to make the experiment. So first, gather a tablespoon, right? The spoon, an empty plastic soda bottle, a pair of scissors, an empty spice jar, a wooden spoon, other spoon of wood, with a long handle, and a container of table salt. With the help of an adult, right? Cut the neck of the pop bottle, right? And fill it. Fill it of what? Fill it, right? About two thirds full with water. What are you going to fill the bottle, right? Then fill about 1/3 of the spice jar with water. Screw, right? Un atornillador. Screw on the lid tightly and places in the pop bottle. The spice jar will slowly sink to the bottom. Now take out the jar and add about 4 tablespoons of salt to the water in the pop bottle. Stirs around until it dissolves. Place the jar back in the bottle. Has anything changed? Try stirring in another 4 tablespoons of salt. Does that make a difference, right? At some point, the jar will begin to float. The more salt you add, and the higher the jar, right? Higher the jar will float. Do you know why? The salt makes the water denser or heavier. Right? That means that it can push back on the jar with greater buoyancy force, right? The more force there is pushing up the jar, the better it will float. So this experiment is about the salt. What causes, or what kind of reaction the salt causes to the water? And you're going to see, you're going to observe what's going on with the materials, right? With the materials, right? So it's super interesting, this topic, because we can see that this law is very important, right? To find and know about what materials float and others sink, right? The classwork is super easy. We're going to make the answer these questions, right? Devon, right? Devon is a name of a person, had a glass marble, right? A glass is like a cup of glass, and a grape, the fruit, right? The grape, that were about the same size, right? So imagine the glass is very small. He placed each one in a glass of water. The marble sank, obviously, right? The marble is going to be under. Super easy, right? And the grape floats, right? This is because option A, the grape was denser than the marble. I don't think so. The marble was denser than the grape. I think so. He used fresh water. He used salt water. The water is not going to be anything in here. So I think the marble was denser than the grape for the reason that marble sank, right? Number 2, write true or false of next statement below. If an object weighs 9 pounds, right, 9 libras, if an object now weighs 9 pounds, it will displace 9 pounds of water. Yeah, it's true, right? The video of YouTube explained very well that every object in the water displays the same amount of the weight, right, of the object. Number 2, the saltier water with salt, the saltier water is, the more easily things will float in it. The saltier water is, the more easily things will float in it. I think it's true. The force of buoyancy causes objects to sink. I think no, it's the opposite, right? All objects have the same density. No, it's not true, right? The pen is not the same, depend the material. The iron is not the same density with the wood, for example. The other is about more questions. When you get into a bath tube full, right, full of water, the level of water rises. Explain why this happens. Super easy, right? Imagine you want to know which of two substances was denser. If both objects were the same size, how could you figure this out, right? And the last one, in the experiment, what do you need to fill the spice jar? This one is, don't do the last one, right? I think only this one is very important. It's about the experiment, right? So, answer in your own words, but the most important thing is that you have to know is that we have objects that float and objects that sink, and why and how is the buoyancy force work. This is the most important of this topic, to know how this law of Archimedes, right? If you find in YouTube, you can find more examples and you're going to define and understand this topic better. So I add a YouTube video next to this, and it's going to help and it's going to be ready. So time is over. Love you so much, and see you in the next class. Bye bye.